Hello guys, let's welcome to our channel Just Genius. In the last tutorial, we have discussed problem related to BIGOH notation. In this tutorial, we are going to look into some problems related to the BIGOH notation. Okay, in this tutorial, I am going to teach two methods of the how to solve problem related to BIGOH notation. One is related to the from the definition of the BIGOH notation, you can solve this problem, and also by the shortcut you can solve the problem related to BIGOH notation. Means the shortcut means even the shortcut all been taught in the previous video. That means you have to drop lower order terms and also constant terms. That is nothing but a shortcut. I am going to teach two methods on this one. Let us start our video now. Okay, here is the first question shown on the screen. Now we have to calculate, find the upper bound of running time for a given constant function f of n equal to 8012. First, the function is given. First, you have to identify what type of the function is given. F of n equal to 8012 is a constant function. For this function, you have to find upper bound running time. For that is nothing but in BIGOH notation. When you recall this upper bound running time, you have to get in your mind like BIGOH notation. So before going to BIGOH notation, you have to know two conditions in the BIGOH notation. Okay. Now in the BIGOH notation you have two conditions, that is f of n less than into c, or equal to c into g of n, where n greater than or equal to n naught, and also f of n equals to BIGOH of g of n. When this condition gets true, then f of n becomes BIGOH of g of n. Okay, by this definition of the BIGOH notation we can solve the example 1. Okay, let us look into this. So given function f of n is equals to 8012. F of n is already given. Now you have to find, so we know that f of n less than or equal to c into g of n. Okay, so you have to substitute f of n value here. Now c into g of n. So in the place of g of n we have to substitute 1, because the function is constant function, so you have to substitute g of n equal to 1. Okay, if I substitute c of n equal to 1, now substitute c, so that 8012 this value becomes less than or equal to this value. Okay, substitute any value of the c here. Now if I substitute c value 1, it will false, c value 2 false, 3 4 false false. If I substitute c equal to 8012 less than or equal to 8012 into 1, now it becomes 8012 is equals to 8012. This condition becomes true here. So this, if I substitute c equal to 8012, so this condition becomes true. For c equal to 8012 the condition becomes true. So now now if the condition becomes true, then answer becomes f of n equals to BIGOH of g of n. So here g of n is we have taken as 1, so substitute 1. This is the final answer. It means that, so I will show with graph. So on x-axis you are going to take input size. On y-axis you are going to take time. Okay, if I draw this graph of the BIGOH notation, you know that this is, I will show you. Okay, this is f of n, this is c into g of n. In the BIGOH notation, c into g of n always dominates f of n. From where point? From this point, always c into g of n is greater than the f of n. This point is nothing but n naught. Now c into g of n is greater than f of n. This is the graph of the BIGOH notation. This graph is taught in this BIGOH notation lecture. You can watch the BIGOH notation once. If you don't understand, please watch again. So when you look into this n naught, we have to find the value of the n naught. If you see, so Here n greater than or equal to n naught. Observe this point very carefully. N greater than or equal to n naught. So I have to find n naught value. To find the n naught value, once you look into one's graph, C into G of n means, so 8012. So you can substitute any value greater than 8012, so the condition becomes true, because so here it is given like 8012 equal to 8012, means you find that you substituted value of C equal to 8012, so you got 8012 into 1, so 8012. So if you substitute any value of 8012 greater than 8012, so condition becomes true. Suppose I will show with example now. So observe this point very carefully. So if I substitute in this place of C, if I substitute C equals to 9012, so this becomes true. So if I substitute in the place of C 8013, this becomes true. Any value greater than 8012 becomes true in that condition. So answer is BIGOH of 1. So when we look into this graph, so when you look into this graph, so now n naught value becomes 1. Understand how did you get n naught value? So n greater than or equal to 1. So you can substitute value of n from 1 to any one greater than 1. Okay, not less than 1. From this point, okay, from this point the C into G of n dominates f of n. Okay, this is, we can solve by the definition of the BIGOH notation to the problem. Now when we look into the shortcut, when you look into this shortcut, so f of n equals to 8012. We know that from the BIGOH notation, f of n equals to BIGOH of G of n. So BIGOH of G of n means you directly write G of n equal to 1, because given function is a constant function, so that G of n becomes 1. Okay, understand? This is nothing but shortcut method. When you look into the constant function, directly write 1 in the place of G of n, so you can get the answer f of n equal to BIGOH of G of n. Okay, this is first problem. Once if you see this first problem once again, so first when you recall this upper bound, you have to know this is problem related to BIGOH notation, and check the function, which function is given. Here is given constant function. Now recall this these two conditions related in BIGOH notation, and apply and substitute f of n 8012 in this place, and substitute G of n. So function is constant, so substitute G of n equal to 1, and substitute C value, so that f of n becomes less than or equal to C into G of n. So substitute for a particular value of C, this becomes, at the finally you will get f of n equals to, at final you get f of n equals to BIGOH of G of n. Okay, in the question if we ask to draw the BIGOH graph of this one, like you have to draw graph like this. You have to draw graphs like this. You have to show n naught value. You have to show n is drawn on x-axis, size is taken on x-axis, time is taken on y-axis. Okay, and C into G of n dominates f of n. You have to show these points when he asks to draw graph. So this is first question. Now when you look into the second question, so when you look into the second question, you will see We have to find upper bound running time for a linear function. Here function is linear function. First identify the function, next you can solve problem related to this one. So the given is upper bound we have to know this is related to BIGOH. The symbol is like this, BIGOH. So when the BIGOH notation is used in the worst case scenario, so recall the two identities in the definition of the BIGOH notation. The two identities are f of n equals to f of n less than or equal to BIGOH of g of n, and along with this f of n equals to BIGOH of g of n. So not this, not this. F of n is less than c into g of n for n greater than or equal to n naught. So these two identities you have to remember. So here question, in the question itself is given a linear function. Once when we look into this function, f of n equals to 4n plus 5. So we have to substitute this one and calculate the time complexity. Also is given answer here, BIGOH of n. Answer is BIGOH of n. I will teach both in the shortcut method and the definition of this BIGOH method. So when you look into the definition of the BIGOH method, f of n less than or equal to c into g of n. F of n less than or equal to c into g of n. So f of n value is 4n plus 5 g of n. Now f of n 4n plus 5 less than c into, substitute in the place of g n. So function is constant, you substituted 1. So function is linear, you substitute the highest term degree here. So here linear function, so you substitute n. Okay, understand how we are going to substitute the g of n value, you have to understand. So substitute. So for a particular value of the c, the 4n plus 1 becomes less than or equal to c into g of n, c into n. Okay, so if I substitute c equals to 1, n equals to 1, so c equals to 1, n equals to 1. So it becomes 4n plus 5 less than or equal to c into n. C equals to 1, n equals to 1. Okay. So if I substitute n equals to 1, c equals to 1, here 9 I will get, here 1 I will get. So not satisfied. So it is not satisfied. So substitute another value. If I substitute c equals to 5, n equals to 1, so the value becomes 4. This is the value becomes 4n plus 5 less than or equal to c into n. So this side the value becomes 9. This side the value becomes 5n. Okay. So if I substitute c equal to 9 and n equal to 1, so this is also wrong. This is also wrong. So if I substitute, so 4n plus 5 less than or equal to c into g of n. So g of n is nothing but n. So if I substitute n equal to 1, c equal to 9, so this side I will get 9, this is 4. If I substitute 1 here, 4 plus 5, 9 less than or equal to c I will substitute 9 into 1. Okay, then I will get 9 equals to 9. So this condition becomes true for n greater than or equal to n naught. Okay, so n value greater than or equal to 1, because I substituted n not equal to 1. here, so n value becomes n greater than or equal to 1. Understand how I got n value, n naught value here. So this value becomes true. So the final answer becomes f of n equals to big O of g of n. So in the place of g of n, you have taken n. So answer is big O of n. Okay. So if you draw the graph, so input size, time, so f of n. F of n is nothing but 4n plus 5. So c into g of n. Here you can substitute, you can directly write, in the place of f of n you can write 4n plus 5. In the c into g of n, what value you got for a particular value of n, you have to write that value. From here, c into g of n dominates f of n, n naught. Now n naught value becomes 1, so n greater than or equal to 1. Why I got n naught value equal to 1 means I substituted n value equal to 1 in the question while solving this problem. You can see here. Here in this place of n I have substituted 1, so n equal to 1 and c equal to 9. So this is important step. So the answer becomes 9 less than or equal to c into 1, 9 into 1. So this condition becomes true. This condition becomes true. So n naught, n greater than or equal to n naught. Okay. This is how to solve according to this BIGOH notation. Answer becomes f of n equals to big O of n. Now when we look into the shortcut, if you open like this shortcut, the f of n equals to 4n plus 5 has been given. Now shortcut here, it is a linear function. First you have to drop constant terms. First drop the constant. First step, drop constant. First if I drop the constant, 5 can be dropped. So f of n equals to 4n. Okay. In the second step, drop lower order terms. Lower order terms. So if I drop the lower order terms, so 4 can be dropped. Now f of n becomes big O of n. This is final answer. This is the final answer. Okay. According to this shortcut method, we have to apply two conditions: drop the conditions and drop the lower order terms. So you will get the final output. Okay. We have discussed two examples. Two more examples we will discuss in the next video. Thank you. Each and every material of these data structures and algorithms will be posted in the description box. You can access the drive link from the description box. If you like this video, please like, share and subscribe.